Hi everyone, welcome to my channel Suraj in Cloud. And in this series of EKS Tales, in previous episodes, we have seen logging, envelope encryption of secrets, and various bits. In this episode, we are going to see how we can manage authentication to the cluster with the help of IAM for various users and the teams, right? So we'll use few examples to demonstrate this particular thing, right? So let's quickly get it. So as we said, today's topic is cluster authentication. Now one very key thing to note here is whoever creates the cluster, whether it is IAM user or IAM role, is always the admin for that cluster, right? So they automatically gets added to the system masters group in the Kubernetes. That means they have all the access on Kubernetes, right? Now the one who creates the cluster, they not only make Kube API call, but they do AWS API calls as well to create the cluster, right? So to make a note of this user or role is very important because this has all the powers to that cluster, right? Now all this IAM stuff, right, or the mapping between IAM roles and the Kubernetes user is kept in this config map called AWS auth. Now this config map lives in kube system namespace. Now once we jump onto the cluster, we will see how that config map looks like, where it is, and how we can manage the access, right? Now this is the important location for us, right? Now on next slide we can see how does this config map actually looks like. Now we don't need to manually populate this config map, it's already there in the cluster. Now when you are in the process of creating a new cluster, and let's say if you have spin up a control plane, you may not seen this config map there, because when I was trying and I spin up the control plane, I couldn't see that config map. As soon as I created a node group and then node group were trying to join the cluster, then I saw this config map was populated. But if we are provisioning the cluster programmatically, it's worth worth creating this config map manually and managing via the code, right? Now as I said, the config map was created when nodes were joining the cluster. As you can see, these are the default values of that config map, and you can see there are two groups, system bootstrappers and system nodes, and they are being assigned a role, which is this EKS node role. Now I have kept that role for node groups when I was spinning up the nodes, right? And the username would be the system node EC2 private DNS, means name of that EC2 machine or something, right? So basically, if any node which is trying to join the cluster needs to have this IAM role, and mapping for that IAM role is these two Kubernetes groups which node entity should be in, right? So this is the basic configuration which is by default there in AWS auth config map when it is populated, right? Now if you see, there is one more thing here, it says map role. So either you can map roles, means IAM roles, and there will be another term called map users, in which you map IAM users. So I'm going to take example of users in next few minutes. Now before we jump onto the actual cluster and see how things are there in practical, I want to show you this diagram which we will try to replicate, and which will show us like how how we can segregate things based on IAM user role mapping to the Kubernetes groups mapping, right? I will show you all the respective roles, cluster role, and the bindings that I have created as well. But this is the high level diagram which I am trying to which we will try to recreate when we will perform some actions, right? So this is our cluster, and it has two namespaces, team A and team B, right? Now what I want to do as a cluster creator who is part of platform team, I want configuration in such a way that team user from team A should only access team A namespace, and user with a team B credential should only be able to access team B. They shouldn't have team A shouldn't be able to access team B, and team B shouldn't be able to access team A, whereas the platform team should be able to manage everything through the cluster, right? So that is our scenario for that, right? So let's see how that we will perform. But before we perform that, we discuss few things in this config map, and now I will show you how our target config map will look like and how it will actually work in the cluster. So before we actually jump, this is the config map we'll be using, and I'll explain how that will work as well. So the map role section we already discussed. The section which we are interested in, map user, right? Now what I'm going to do is I'm going to take IAM user team A Tom. Now Tom is a part of team A, and I'm going to map it to the team A group, right? And I will show respective RBAC as well how team A has permission to access team A namespace as we saw in the diagram. Similarly, Jerry from team B will have permission will have mapping to the team B group, right? And which will have respective roles in the cluster, right? So this was more about the theory part. Now let's quickly jump into the actual cluster and see how that will work, right? So I am here. So I already have a cluster called Suraj in Cloud -1. I mainly use this name for my clusters. It already has a node group, and that node group is using IAM role EKS node role, which we saw in the config map earlier, that node with IAM role were trying to join system : bootstrapper and system : node group in Kubernetes. Now we have this cluster, and I created this cluster with the help of IAM user called Suraj in Cloud, which is part of platform team as per our diagram, and that will have all the access over the cluster, right? That I will show you now. So get caller identity. So I'm using Suraj in Cloud user, right? Now I'm using Suraj in Cloud user. I have already populated my kubeconfig with this particular command -1. I have already populated in this particular file, right? I already have the file. Now I will export this kubeconfig And now if I do kubectl get ns, or if I do pods in the kube system namespace, I'm able to access everything, right? My current namespace is team B. Let's switch to kube system, and as you can see, I can create the secrets as well. Let's say test from literal foo bar. Yeah, I can list secret as well. Basically, what I wanted to show is currently I am a part Suraj in Cloud user, which is part of platform team, which has access to all the clusters, right? Now, as we said, we have two users, Tom and Jerry, respectively part of team A and team B, and I want them to access their respective namespace, which is team A and team B, and they shouldn't be able to access anything else, right? Also in IAM, as we can see, I have this team A user called Tom, team B called Jerry. Right, now let's go to the Tom user. Okay, let's switch to Tom user. I have added him. If I do this, I am now acting as a Tom, and now if I do kubectl get ns, I cannot access. If I do pods, I cannot access. Or if I do team B, which was my goal, it cannot. But let's switch to team A namespace. I'm in team A namespace, and now I'm not getting any error message, right? I can create pod here. Let's try it. Create deployment nginx image nginx. Oh, I cannot create because I think I don't have appropriate permission, right? But can I just create other things? Okay, so because I think deployment is part of apps v1, I'm not able to do it, but I may be able to spin up the secret, I guess. Generic, and we will also give permission to create the deployment as well. We'll see that as well. Okay, so generic test from literal foo bar, right? So in team A, Tom, you can create this, but let's say if we go to team B, will Tom be able to do this? No, right? Because the IAM mapping is different. Now same, let's see what Jerry can do. Jerry get caller identity. I'm now acting as a Jerry, and I'm in a team B, right? And let's say, can I create this? I can, but if I switch to team A and run the same command, I cannot, right? So as per the diagram we saw, if we go back to the diagram, now team, oh, something's happened to my pen. Oh, my stylus is not working. Yeah, it's working now. So team A was able to access team A, and team B was able to access team B. B couldn't access the A, and A couldn't access the B, whereas the administrator can access everything, right? We had some glitch with deployment. We'll try to solve that as well, but before that, let's jump into the code and see what we did there. Let's look at the RBAC code, what we did. This was the config map, which we already saw in our slides, whereas the map role section was for nodes, and in the map user section we said this is the I'm user, map it to the team A group, and this is the team B Jerry, map it to the team B, right? Simple config map. But let's quickly look at the bindings that we have, how these users are able to access their own namespace. Now let's look at team A role binding. It says team A full access. Now role binding is scoped to that particular namespace, right? So what we are saying here is team A full access role binding, in which group team A will have the role super user. So basically we are giving super user cluster role to that particular group. So whoever is part of team A will have the cluster role super user. Now you must be wondering, if we are giving cluster role, why that user is not having cluster level access? Because in role binding we can also refer cluster role, but it will be still scoped to that particular namespace. Now same applies to team B as well. What we are saying, team B, and it should have, okay, this is something extra. Team B should have the reference cluster role super user, right? So what we said here is team A should have super user, team B should have super user, but scoped to their own namespace, not more than that, right? Now let's look at this super user role that we created. It's very straightforward role. What we are saying is API group, if it is not provided, that means is the default one, core v1, all the resources, and you can just do all the operations on it, right? So if you remember, we couldn't do the deployment, so let's just replicate this thing, and instead of API group, let's say apps. Let's see if we can do this now, right? So I will have to change my user to my admin user, and let's apply this RBAC that we did. Okay, it did applied. Okay, now if I change to my Tom user, okay, and I'm still in team A, and I think now I should be able to create the deployment. Let's see, fingers crossed. Nice, I'm able to create the deployment as we updated the RBAC, right? Now if I go to team B, can I do it? No, I won't be able to do it because my access is scoped to that particular namespace. Now let's try the same for our Jerry user. Okay, so let's go to Jerry user, and I'm still in team B, and if we create the deployment, I'm able to create the deployment, and if I go to team A, I won't be able to create the deployment, right? So this is how you can manage the access. Now you must be wondering, like, based on IAM, how it is getting the credential. So basically when we do sts get caller identity, and whatever token this command sends us, IAM based authentication uses same kind of mechanism to go with it, right? So now in this particular scenario, I'm not using anything additional tools. I used kubeconfig, which was created by AWS CLI itself, which uses AWS EKS get token command to get the token. There are other alternatives such as AWS Authenticator, which you can use, but I just went with the AWS CLI version. And one thing to note as well, you need appropriate version of AWS, which is like most recent version of AWS CLI, right? So yeah, as you can see, whatever we performed, we managed to do this particular diagram, and with help of this config map. Now in some cases you may want to have a CI user which does some sort of information, so in that maybe you can add more users here, right? Or if you want to do some operations with the help of IAM role, which let's say which can be attached mapped to a service account which is doing some sort of stuff, you can map those roles in this map role section. So it's very simple and straightforward. So this is how you can manage IAM based authentication to the cluster, where you can map IAM roles to the Kubernetes groups or users, and you can define various cluster roles and role which you can attach as well to these IAM roles, and with that you can like restrict the user access and manage access at a wider scale. There are still other options which we will evaluate in upcoming videos, and few other interesting stuff around EKS. If you have any suggestion what should I cover in upcoming EKS Tales series, let us know in the comment section. If you like this video, do like it and share and subscribe to our channel. Till then, bye bye.